Now in this question we have to show, or you can write it prove, that the equation of straight lines passing through the points 3 comma minus 2 and inclined at 60 degree to the line root 3x plus y is equal to 1 are this one and this one. These are the two equations, okay, which we have to prove. Now equation of two straight lines passing through the point, say let it be x1 comma y1 and making an angle alpha, okay, with y is equal to mx plus c r. Now what the formula it is? The formula is y minus y1 is equal to m plus minus tan alpha upon 1 minus plus m times tan alpha with x minus x1. Okay, this is the formula. Now, according to question, what is given to us? x1 comma y1 is equal to 3 comma negative of 2. Tan alpha is equal to tan 60 degree is equal to root 3, and let m be the slope of line, that is root 3x plus y is equal to 1. Now this becomes y is equal to negative of root 3x plus 1. Now therefore m is equal to negative of root 3. Comparing with y is equal to mx plus c. Okay. Now all the things we are having. Now case 1. Now case 1 is what? Equation of required line. Y minus y1 is equal to m plus tan alpha upon 1 minus m with tan alpha x minus x1. Okay, this is case 1. Now according to this one we are having y plus 2 is equal to, now m is what? Negative of root 3 and tan alpha is positive of root 3 upon 1, this becomes plus root 3 with root 3 x minus 3. Y plus 2 is equal to 0. Why y plus 2 is equal to 0? Because negative of root 3, positive of root 3 is 0. So first equation was y plus 2 is equal to 0. So proved. First part we have proved. Now case 2 we are having y minus y1 is equal to m. Now earlier we took plus, now it is m negative of tan 60 degree upon 1 positive of m with tan 60 degree x minus x1. Y plus 2 is equal to negative of root 3 upon 1 minus root 3 with root 3 x minus, sorry, in place of x1 let's write 3. Okay, so this becomes y plus 2 negative of 2 root 3 upon negative of 2. 1 root 3 times root 3 is 3, okay, with x minus 3. Now this is equal to y negative of root 3x plus 2 plus 3 root 3 is equal to 0. Proved.